I saw this article today about a new monoclonal antibody in the popular press, and it seemed interesting, so I looked up the paper on it. It's by Eli Lilly and I'm guessing a startup called AbCellera Biologics in Vancouver, and it's called LY-CoV1404. Potently neutralizes SARS-CoV-2 variants. So this is interesting because they're saying that this monoclonal antibody works against all the known major variants. And after reading this study, it is a preclinical study, and I don't really like to talk about preclinical studies because most preclinical things don't end up being clinically relevant. But this one was interesting for a couple of reasons. One is mainly the method by which they found this antibody is very interesting. So let's go, in their introduction, they kind of mentioned this VIR 7831, which we talked about in a previous video, which actually went to phase 3 clinical trials. And I think right now the EU is looking to give it approval. So this might be actually available pretty soon. But let's look at this. How did they find this? How did they develop this antibody? Which I thought was pretty fascinating. Okay, so what they did is 3 different screening strategies were employed to identify SARS-CoV-2 binding autoantibodies from the PBMCs. This is peripheral blood mononuclear cells. So what they do is they draw blood from patients that had undergone an infection with COVID-19. They drew their blood. They isolated the mononuclear cells. These are the white blood cells from their blood. And then they screened all these white blood cells. So what they did, a total of 740,000 cells were screened. So they screened a bunch of these. How they screened them is they used a multiplex bead assay. So what they did is they got the spike proteins from multiple coronaviruses and saw which of these cells had hits on the antibody. So out of 740,000 cells, they had 1,692 antibody hits. So basically 0.22% of these cells had antibodies that recognized the spike protein. So then of these, about 1,062 single antibody secreting cells were selected for recovery. Libraries of antibody genes were recovered from single B cells. So what they did is they isolated the genes and sequenced the genes from these cells. This is amazing. It used to take forever to sequence these things, but now with next generation sequencing, you can do this in, I guess, days or weeks. And so they sequenced all the antibody genes from these 1,062 cells, and then they used a bioinformatics machine learning pipeline to identify what they thought were like the best candidates. And then they went down to 200, so they whittled this down, so they went from 740,000 to 1,692 to 1,062 to 290. And then of these, I guess they picked the one they thought was the best. And then they started testing this one. So they called this CoV1404. I'm guessing this is like the number that it was assigned by the computer when they were screening the 1692 antibody screen. So it's like number 1404, maybe. I don't know exactly how they came up with this name, but it seems to make sense. Okay, so what they did is they, after they characterized this, they found out that it had a KD or dissociation constant of about 790 picomolar. So molar, if you remember from your general chemistry class, molar is moles per liter. And so a mole is basically the number of molecules, and that corresponds to Avogadro's number, which is like 6 times 10 to the 23. And pico means 10 to the negative 12, so it's like a trillionth, 1/1,000,000th of a mole. So 790 picomolar. So it's very low concentrations, and so they're saying that it binds with such high affinity that you only need very low concentrations for this to have binding and that's their dissociation constant. So let's skip all this. There's a lot of nitty-gritty. Yeah, I'll link this paper if you want to read it. They talk about all the different assays by which they tested this. They got pseudoviruses, they got real viruses, they got just raw spike proteins. But the interesting thing is they made pseudoviruses. So these are not fully functional viruses, but they make the spike protein. So these are the major variants of concern: the UK variant, the California variant, the South African variant, the Brazilian variant, the New York variant, and then these are the basically the major mutations in these. And going back to that, it does seem like we haven't heard about any major variants recently, and so it seems like it might be possible that there's convergent evolution of these mutations, and basically there's only a set amount of mutations that the spike protein can do. So hopefully this means that once we take care of these variants, any future variants most likely will recapitulate these mutations and will still work for them. But anyways, what you see here is there's an IC50 and IC90. That means the inhibitory concentration that gave 50% inhibition of the maximal dose. So it's like 50% effective, and this is like 90% effective. And so they are doing this in micrograms per milliliter. So this is 0.003 micrograms per milliliter, or if you want to do it in nanograms, it's 3 nanograms per milliliter, or 2 nanograms per milliliter, or 1. And what this shows is that this thing is actually more effective, so has higher affinity for the variants than for the wild type, because the wild type requires a little bit more. And so I was like, I don't even know if this is good. Is 3 nanograms per milliliter a good IC50? I'm not sure. Maybe they seem to think it's good because they titled it potently. So I went back and looked at this paper on the VIR-7831, which I thought was a very promising monoclonal antibody in the phase 3 trials. And I looked at what kind of concentration were these guys using so in their preclinical studies. So I found it. Let's see, right here. Okay, right here. Okay, so this scale is in nanograms per milliliter. So this, if you remember, this is like 1 to 3 nanograms per milliliter is your IC50. Or if you, let's go to IC90. So this is like 24 to 9 or 5 to 24 nanograms per milliliter. So 24 is right here. It's right here. It's around here on the scale. And so this VIR-7831 was basically about 5, maybe 10% effective at that thing, and they had to crank it up to about 1,000, or maybe about 200 nanograms, 200 nanograms per milliliter before they hit IC90. So yeah, this is like at least 10 times more potent than that drug. So very early. This is preclinical studies. You know, they are almost definitely starting phase 1, phase 2 trials very quickly. You know, things are moving very fast in these pharmaceutical companies with these drugs. If the preclinical potency matches up with, if it stays true in the clinical trials, this will be actually a very effective drug. So we'll be awaiting the results of clinical trials, which I imagine will be out in the next several months. So I think 2 things are very promising. This one is actually more higher affinity to the variants. We haven't heard of any new variants recently, so there seems to be convergent mutations, which mean that further variants are likely to be similar to the current variants, and that this drug and drugs like this will be very effective. And what I think probably is going to happen, they're going to make a vaccine booster for these new variants. I suspect that that's coming out in the next couple of months. And as long as there's no new variants, that'll be a very important step. All right. Thanks for watching.